The input and output that I've shown in the last two modules is known as standard input and standard output. These are technical terms used in Unix. We have a diagram that summarizes this. Any given Unix program can possibly produce output. That output will go to the screen unless it is redirected to a file or to a program. Similarly, input will come, if there is any input, it will come from the keyboard unless that input is redirected from a file or from another running program. We call these standard input and standard output. All of this begs the question, why would we want to do this? What's the point? It seems rather complicated connecting all these programs together. Why would we want to do that? The answer to this question requires us to know something about Unix philosophy. The people that designed Unix, or at least the Unix utilities, figured there were far too many tasks that people might want to do. They couldn't possibly conceive of every task that anyone who ever used Unix might ever want to do. So what they thought they'd do is they'd provide them with a whole bunch of very simple utilities, which they could then join together as they needed. Obviously this assumes that the people who are using the utilities are reasonably technical, but in those days everyone that used Unix was. You really didn't use Unix at all unless you were probably the member of a computer science department somewhere in some university. So anyway, their philosophy was to provide all the tools, all the building blocks if you like, and then the users could put them together as needed into more substantive programs. And so it goes that most of the command line utilities that you see are quite simple. They produce output in a very simple way that is consistent with all the other ones, which enables them to be used as building blocks in more complex programs. This approach, which I guess you could call the roll your own approach, has proved very successful. It makes Unix shell scripting a very powerful way of specifying tasks that need to be done. What we've seen so far is just the foundation. If you were to learn about Unix shell scripting or shell programming, you would see this carried to a much higher degree. I'll just give you a brief example of just a one-line program, just a simple program that you could create yourself that uses several different Unix components to produce something that doesn't actually exist. Suppose I want a program that will tell me the number of times that the root, the super user, is logged into the system. I want that information to be printed out on a line printer. So I could think of the command as, please print for me on the printer the number of times that root is logged in. Is there a command in Unix to do that? Of course not. It's rather too obscure for that. So we simply make our own from the various utilities that are available. The first one is, well, the who program, which tells us all of the users that are currently logged in at the moment. Then we pipe the results to grep root. Now you haven't seen grep yet, but you will shortly. What grep root does is it filters that list down till I just see the lines that contain the word root in them. Then I send the results of that to wc-l, which counts the number of lines produced by the grep program. So instead of seeing all the instances of root being logged in, I am now counting the instances and producing a number. And then I send the results of that to the program called LP, which is the line printing program. And so I'm using 4 programs to produce what I need, all piped together in one long continuous stream. And that is actually a fairly simple example compared to some of the shell scripts that you will see around the place. And if you can master that, then you've mastered a very, very powerful tool. I'll leave you with one final question from this module. What is the difference between the following? Who greater than LP and who pipe LP? What is the difference there? Have a think about that, and now I'll tell you the answer. The first of those two will actually create a file in the current directory that is called LP, and the results of the who program will go into that file. The second command will take the results of the Who program and send them to the line printer via the program LP. So in the first instance, LP is interpreted as the name of a file. In the second instance, LP is interpreted as the name of a program. You'd be amazed at the number of people that get these two confused. I'm not talking about this specific example, but the number of people that confuse the greater than form of redirection and the pipe form of redirection is, well, it's a very large number of people. Please try and make sure that you're not one of them.